Blackbody radiation refers to the spectrum of light emitted by any heated object. Common examples include the heating element of a toaster and the filament of a light bulb. It is a common phenomenon observed when the temperature of an object increases. The electromagnetic radiation occupies a wide spectrum, both in the visible and invisible regions, depending on the temperature of the object and amount of radiation. All objects are blackbody radiators. The amount of radiation and position in the spectrum depends on the object temperature as well as its emissivity. Some examples that emit visible light or whose radiation is used for other processes like electric heaters, incandescent light bulbs, stoves, the sun, the stars, night vision equipments, burglar alarms, warm-blooded animals, and many more. A blackbody radiation in a filament bulb converts the electrical energy into light energy at switch on or switch off. When the filament is not fully heated or cooling down, it radiates energy in the infrared regions initially and goes to red, then yellow until it reaches an almost white light when fully energized. An object that is not very hot still emits radiation, but in the infrared region. This is utilized in night vision equipment, which is used to detect the infrared radiation and convert this into a visible image. This allows the detection of warm-blooded animals and people at night. Usually, the blackbody radiation from animals is in the infrared radiation, which cannot be seen in the naked eye. However, by the use of thermal camera and thermal radiation from the animals can be seen. The image appears as a glowing object due to the blackbody radiation, unlike during the day when the person reflects the light falling on them. A hot or warmer objects emit more energetic radiation and cool faster than the cooler objects. In the absence of the heat source, the objects will eventually reach the same temperature as the surrounding and are said to be in thermal equilibrium. Physicists contemplated blackbody radiation wildly by Try and thought a lot about it by 1900. Yet, little was perceived until some very progressive changes in physics. Not just did the issue of blackbody radiation recommend the particle of nature of light, however, it additionally prompted the field of quantum physics. An ideal blackbody is basically an item that transmits as much light as falls upon it from its current circumstance. As the temperature of the blackbody rises, the wavelength of the light transmitted with the most noteworthy force diminish, making a spectrum with a trademark shape. Physicists progressed a lot of hypotheses as to exactly how a blackbody functioned, yet every theory was inadequate. The best case scenario, it could coordinate with just a single piece of the spectrum at low wavelengths or at high wavelengths.